In this presentation, we're going to look at a finite series. That is to say, the summation of a sequence. So here's an example. Consider the sequence defined by the following expression. U of n equals n squared minus n plus 1. Showing all your workings, compute the sum of the first 100 terms of this sequence. Before we begin, we should remind ourselves of some very important theorems that we're going to use. So, for example, theorem 1, the summation of the constant value 1 n times will give us n. The summation of k n times, where k increments from 1 to n, is given by that expression there. Two more complex theorems this time. The summation of k squared, where k increments from 1 to n, and x to the power of k, again when k increments from 1 to n. There's a special condition attached to theorem 4 that n cannot equal 1. It doesn't work in that case. So let's begin. So our expression from before was u of n equals n squared minus n plus 1. What we're going to do is take each of the appropriate theorems, and what we're going to do is add up the solutions of each. So just to be clear, we're adding up the first 100 terms of this sequence here. So n is going to be 100. So that's how we would write that there. Now, n squared, we're going to use theorem 3. N, we're going to use theorem 2. And 1, we're going to use theorem 1. Just be mindful of the signs as well. There's a minus sign here, so we're going to be very careful about keeping that minus and plus sign in our minds and in our calculation. There's a plus there, so we keep that as well. What we're going to do is work backwards. So we're going to do this one first, because it's the simplest. Then this one. It's a bit more complicated, but not as complicated as this one here. So first off, we're going to start with using theorem 1. So from before, all we have to do it's just equal 100. Now let's just double check theorem 1 again. Yeah, there we have it there. In this case, we're going to use theorem 2. Now, just to remind ourselves, this is equal to n times n plus 1 all over 2. So that's equal to 100 times 101 all over 2. Using our calculator, we would evaluate that to be 5050. Okay. And moving on to the last expression, this time we're going to be using theorem 3. Now this is a bit more complicated this time. So n plus 1, 2n plus 1 all over 6. Now that's equal to 100 times 101 times 201 all over 6. Now, using our calculators, we would find that to be 203,0100 all over 6. And that's equal to 338,350. So let's put this all together. So we know this to be 338,350 minus 5050 plus 100. So the overall answer is 333,400. So that is the sum of the first 100 terms defined by that sequence. So that is our answer.